Okay, STAT1150, the purpose of this video is to get into box plots a little more, but I want to pump the brakes just a little bit and give you some information about the relationship between means and medians dependent on the shape of the distribution. So you can see on the right-hand side, I've just typed out the relationship, what we can expect to see between the mean and the median when we have a bell-shaped and symmetric distribution, a right skewed distribution and a left skewed distribution. And just as I've reported there, the mean and the median will be equal to each other or very, very close to each other in a bell-shaped and symmetric distribution. If we have a right skewed or a positively skewed distribution, the mean will be greater than the median. And if we have a left skewed distribution, the mean will be less than the median. So in a way, we say that the mean chases outliers. Now, what do I mean by that? Well, think about it. If we have a right tail distribution, the distribution is probably right tail because there are high values of outliers. If we have a left tailed, a left skewed distribution, then that probably means that we have some very low outliers, pulling the distribution, pulling the tail of the distribution in the particular direction of the outliers. So in other words, outliers actually cause our skewness. So to simplify, this is one of those things in mathematics where it's almost like a what we call an if and only if statement. So if someone tells me that the mean is 102 and a median is 80, because the mean is significantly higher than the median by 22 points, then I can conclude that very, very likely that the distribution is positively skewed. The reverse of that is if someone gives me a histogram and I can examine the distribution, which I can do right here, and conclude that it's a negatively skewed distribution, then I really, I can make an estimate of the mean and an estimate of the median, but I can be pretty much guaranteed that the mean will be less than the median. Now, this is an important concept, so it's an important enough concept for me to dig a little bit deeper. So that's what I want to do right here. So you can see what I've done. Well, first of all, I've got this data set on bare measurements, and I want to take a look at some box plots of some of the quantitative data here, and I'm going to even bring in some categorical stuff as well. But the first time, before I get to that, I want to actually give you an illustration that hopefully makes the relationship between the mean and the median and chasing outliers and outliers causing skewness and all that. I hope that we can make that a little clearer. Now, what I have is I have this extra data that I created, and I created this to be perfectly bell-shaped and perfectly symmetric. So if I grab a histogram of the extra data that I've added in, has nothing to do with bears, okay? And I come down, I put markers at the mean and the median. What I'm going to get, because I constructed it this way, is a bell-shaped and symmetric distribution. Now, there should be a green line for the mean and a red line for the median. We can't see the red line because the green line is over top it, but we can see that the mean and the median are equal to 5. Now, let's add some outliers. So I would suspect that 15 is going to be an outlier, and I would suspect that 25 is definitely going to be an outlier. So again, let's go back over here. Outliers cause skewness. So let's look at a graph now of the histogram, the same data set, but now we have the data set added 15 and 25. And we'll look at the mean and the median markers. And what happened? That nice bell-shaped and symmetric distribution became positively skewed because of the outliers. And notice that the green line, which is the mean, became 6.67. In the presence of outliers, the median didn't change. That's why I make the second comment, or I'm sorry, the first comment, that the mean chases the outliers. Now, let me show you how a box plot would be calculated with this or constructed with this. Same thing. Let's get the extra data. I'm going to draw this horizontally. If you leave this blank, it'll draw a vertical box plot, which is perfectly fine. And I'm not going to put the markers in because we know what the median is. And you can see what happened, right? The outlier 15 and 25, the two data points that I added. This value right here, of course, is the median. And then if you notice the pop-up box that you get by hovering over tells you how many values, number of outliers, IQR, Q1, Q3 median, gives you the 5-number summary. So it's pretty nice stuff. Now, probably goes without saying, but I've been teaching long enough to know that nothing goes without saying. What if the outliers had been on the other end? So let's add a -10, and then let's add a negative, whatever, 23. It's my wife's birthday, so let's go with that. Histogram. So what's going to happen? We're going to get a negatively skewed distribution. And notice how the median stayed consistent and unaffected in the presence of outliers, and the mean chased the outliers. So let's make some pretty important statements here. I've actually got this in a Word document. In a skewed distribution, the most appropriate measures of center and spread are the median and quartiles. The median is our measure of center. The quartiles are our measure of spread. In a symmetric distribution, the most appropriate measures of center and spread are the mean and standard deviation. All right, hugely important. Major, major, major importance. I'm gonna make it large so it gets tattooed to the brain, right? Now, this, all kidding aside, this should go into in your notes and with big old flashing neon lights around it. Now, let me pump the brakes a little bit and keep it real here. In all the studies that I do and the descriptive statistics that I report, I always report the mean and the median. I'll always report the quartiles, and I always report the standard deviation. However, it's important to know that depending on the type of distribution you have, which measure of center, if you're forced to use one as representation, which one are you going to use? The mean or the median? Well, it depends on the distribution. Symmetric distribution, we'll report the mean as the primary measure. In a skewed distribution, we'll report the median as the primary measure of center. And after that, the spread is really, the standard deviation is the spread about the mean. If you think back to the formula, what did we do? We took x minus x bar. We built the standard deviation around the mean. Therefore, if we decide on the mean as the as the measure of center, then we should select the measure of spread that is built around it. Well, same thing with the median. What measure of center is built around the median? Well, if we go 25% one way and 25% the other way, we create these quartiles, Q1 and Q3. So the quartiles are built around the median, so it would make sense that we report the quartiles when reporting the median. All right, again, major, major information there. So Uh, try to get that in. Don't try to get it. Definitely get this in your notes. All right, so let's talk a little bit about box plots. That's what's it's kind of been on our agenda, on our radar. I'm going to just wow, that's good. So let's take a look at some of these neck, length, and chest, and see what's going on. So if we want a box plot, we just go to box plot, and I am going to go down to the weight of the bear, and I want to draw the boxes horizontally. I'll tell you what, let me leave that unchecked, and let me show you what that looks like if we draw a vertical box plot. Now, I don't really need the markers. This is really nice for histograms, but for box plot, I don't care much about that. So there you go. We have the 5-number summary. We can hover over that, and we can get the lower value, the upper value, Q1, Q3, and the median. We can also get the IQR, and we can see that there's one outlier. There is a humongous bear out there somewhere at 514 pounds. Um, Now, if we want to stick with the horizontal box plot, again, easy to do. So really, there's no right or wrong. It's just a matter of which one that you prefer. Now, what if we wanted to, and notice too that this line right here, the median is 150. If I draw that line right down to the scale, to the horizontal axis, you can see it intersects at 150. Q3 is 236. You couldn't eyeball it, or at least I couldn't, and determine 236. But you could get a pretty good estimation on Q1, which is this vertical line, the median, which is this vertical line, and Q3, which is this vertical line. This is the lowest value in our data set. This is the highest value in our data set that is not yet an outlier, and this is an outlier. So there are no values between here and here. All right, so what if, I noticed in this, well, I'll tell you what, I could just bring that back. Um, what if I wanted to look at this, examine this over sex? So it looks like they have the sex of the bears. Looks like one is male and not really sure. One is male and 0 is female. Okay, so if I wanted to examine a box plot, we call this a side-by-side box plot. I could bring in weight, and then I could group by sex. So now what I'm going to get is I'm going to get 2 box plots, one for male, one for female. And it gives me a super, super, super good way of comparing the distribution of weights. Now, hugely important. So tunnel vision. Get this written down. When I examine a box plot, I have 3 things in mind. Number 1, I want to compare the centers. Number 2, I want to compare the spreads. And number 3, I want to examine the outliers. Again, let me repeat that. Center, spread, outliers. Let me repeat that. Center, spread, outliers. Okay, I'm sorry. So when I look at these box plots, looks like again 1 was male and 0 was female. So the males are up here. When I look at the center, I can see that the median is 154 and the median is 140. So the median weight of the male bears is higher than the median weight for the female bears. Next thing I look at is variability. This line from here to here indicates there's more variability in the bear scores than there are from here to here for the female bears. Also, I can look at this and I can see that the IQR is 246, the IQR is 128. So the variability of the weights of each of these bears, according to sex, the middle 50%, there's more variability for the female, I'm sorry, for the male bear. Now, when we partition these bear weights out into gender, notice there are no outliers. So I would report, there are no outliers when the distribution of bear weights are presented across gender. All right, so we might want to just kind of mess around a little bit and maybe look at something else. Let's see what the neck would look like across gender. Again, center spread outliers. The median is higher for male bears than female bears. The variability, if I go from here to here and here to here, I don't see a lot of difference in the variability. However, I see that the IQR is 10 here and the IQR is 6.5. So the variability of the middle 50% is more for the male bears than for the female bears. And again, I can report there are no outliers for the weights across gender. Now, another data set I have up is the Disney. And the one we looked at, or the variable we looked at earlier was Space Mountain for the 10 a.m. So just to show you how I got this, probably pretty obvious now. I went to Boxplot. I chose the 10 a.m. Variable, and I presented horizontal box plots. And this is, again, the PowerPoint that we looked at earlier. You can notice that these two values are the outliers of 105 and 125, no, 110, okay. And so anyway, just wanted to show you how that is very, very easily gotten. One thing we can do is, let's say we take Space Mountain and we are doing a histogram and we want to overlay a normal distribution. So we can look at our histogram of Space Mountain wait times. We can overlay what it would look like if we had a normal distribution and make comparisons. And I'm going to add in the markers on this one just to make a point. Now, what do I know? Well, the red line here is a normal distribution, which you're going to learn ad nauseum here in a couple of lessons. The distribution does not look like it came from a normal distribution. Notice that the red line, which is the median, is less than the green line, or I should say the green line is greater than the red line. So that indicates to me that we have a slight positively skewed distribution. And the separation right here indicates to me that we probably have an outlier. And again, we don't get outliers from histograms. We get outliers from box plots. All right, gang, I could go on and on and on, just really repeating a bunch of stuff that I've already presented to you. So I think we've covered enough. Let's wrap this one up.